Hello, in this video I am going to discuss some problems that are given in University Physics Volume 1, and this book is from the OpenStax, and this book is written by Samuel J Ling and others. So I am going to discuss some problems from this book. So the first problem that I am taking is this problem 123, and that problem is in this challenge section, challenge problem, and this problem is from chapter 10, that is given on page number 524. So here we are given with a disk, and this m is indicating the mass of the disk, r the radius of the disk, and this a is the area of the disk, and the surface mass density that is given by this symbol sigma is equal to mr divided by ar, and he is saying to see the figure. So this is the given corresponding figure. What we have to find out, we have to find the moment of inertia of the disk about an axis that is passing through the center. So as this problem is in the challenge section problem, so this is a challenging problem, and what physics we have to look for in this question is the main challenge here. So the first thing we have to look here is about the mass density, the surface mass density. Now from this equation, it is clear that the surface density is a variable of r, means this sigma depends upon r. Now what is r here? R is basically the distance from the center of the disk. As we move away from the center of the disk, this small r changes, and when this small r becomes equal to r, means we have reached the rim of the disk. Clear? Or it is showing us that this sigma is variable, means the mass density is variable, or you can say that the mass distribution of this disk is not uniform. So I am writing that this is indicating that the mass distribution is not uniform. So this question can be solved by using calculus, and I am going to solve this question for you. So I am switching the window. So now the same question is here. Now in order to solve this question, what you have to do, you have to first draw this figure. Now this is the disk, and the radius of the disk is r, and the axis is passing through the center of the disk. Now this disk has to rotate about this axis. Now this sigma depends upon r, means sigma is a function of r, m by ar into r. Clear? Now what we have to do, we have to choose an elemental ring here. We will choose an elemental ring. So consider this ring, and let the thickness of this ring is dr. Dr is what? Thickness of the ring, and let the radius of this ring is r, because r is here the distance from the center of the disk. Clear? Now we have chosen this elemental ring. Now can you tell me that what will be the area of this elemental ring? Area of the elemental ring. So the area of the elemental ring is 2 pi r into dr. The length of the ring is 2 pi r, and the breadth of the ring is dr. So the area is length into breadth, and that is the area of the elemental ring. Now why we are calculating this area of the elemental ring? Because we are interested in calculating the moment of inertia of this ring, and then we integrate this function that we will get for the moment of inertia of this ring for the whole disk. So our objective is to find the moment of inertia. So first we will find the moment of inertia of this ring, and then we integrate it for the whole disk. So the small amount of moment of inertia of this elemental ring is mass of this elemental ring multiplied by the square of the distance. Because it is a ring, so the moment of inertia is mass into square of the radius of the ring. Now what is this elemental mass is our next concern. So as we have calculated the area of the elemental ring, so the mass of the element is the mass density. The mass density is mr divided by ar into 2 pi r dr. So that is the area, and this is mass density. Mass density means mass per unit area. So you will get cancelled this area by area, and you are left with the mass. So dimensionally this equation is true. So this dm is the mass of this elemental ring. So if you put it here, you will get m, this r, and this r square will give you r raised to the power 4. This is dr, so I am writing here dr. So I am left with 2 pi, this 2 pi m I have written, divided by ar. So that is the moment of inertia of this elemental ring. So I have got this function for the moment of inertia. Now in order to find the moment of inertia of the complete disk, what I have to do, I have to integrate it. I have to integrate it. Integration means if I take other elemental rings and find out the moment of inertia of all other rings, and then if I add them, I will get the moment of inertia for the whole disk. So that integration indicates that. So this will give the moment of inertia of the complete disk. So if you integrate it, you will get 2 pi m, and the area of this disk is pi r square, and here we have this r also, so this is pi r cube. And if we integrate this r, now this small r is changing from 0 to r. So if I integrate it, I will get r5 divided by 5, and if I put the limit 0 to r, so finally here I am writing it. So I will get moment of inertia as 2 pi m divided by pi r cube, and here I will get r5 divided by 5. So this r cube, and I'm left with r square, pi will get cancelled. So the final moment of inertia will be 2 by 5 mr square. So that is the moment of inertia which we are looking for. So that is the moment of inertia of this disk about this axis of rotation. Now the next important question that I'm going to discuss is this question number 129, and that question is in chapter 6 on page 312. Now in this question he is saying that you will find that the weight of particle varies with altitude such that this weight is mg into r naught square divided by r square, where r naught is the radius of the earth and r is the distance from the earth center. So if the particle is fired vertically with velocity v naught from earth's surface, determine its velocity as a function of position r. So in this question, what he is trying to convey that the weight of the particle varies with latitude. So I have pasted this question here, and what he is trying to convey that, say this is the earth, this is the center of the earth, and from this center of the earth you can say that this is the radius of the earth, which is given here, radius of the earth. It's given r naught. R naught is the radius of the earth. Now he is saying that as you move towards an altitude that is given by r, and that is measured from the center of the earth, the acceleration due to gravity varies, means g varies. Clear? So he is saying that the weight of the particle varies with this. So what he is trying to convey, that weight is a function of r. Weight is a function of r. So here it is given r. This means as you move up, weight of the body decreases. Weight of the body decreases as you move up. Clear? Now, what he wants us to solve is to find the velocity. Say this is the point P at any instant of time. Then he is asking that what is the velocity of the particle when it is here. Because as the particle is moving up due to the gravitational force of the earth, the velocity of the particle will definitely change. But here, the velocity of the particle will change according to the variable retardation. Variable retardation. Earlier in motion under gravity, where you take g as constant for motion near the surface of the earth, but here as the altitude is increasing, the acceleration is not constant. That is given by the statement that the weight of the particle is varying. Now, how the weight of the particle is varying, this means that the acceleration due to gravity is not constant, it is varying. So the particle here is moving under variable acceleration. Now, what is that variable acceleration? So that you can find from the given result. So I am writing this weight as m g r naught square by r square. Now this is force. Force is mass into acceleration. So we are given with this acceleration. So this is the acceleration, or you can say retardation in our situation. Its value given as g r naught square by r square, and also we know that this acceleration is equal to minus dv by dt. Why we have put minus? Because it is a retardation. So acceleration or retardation is the rate of change of velocity. Now this question is purely a calculus based question, and he has also given us the hint here that how to use the acceleration term or find the acceleration term. So I am writing this equation like minus dv by dr by dt. So I have used the chain rule in the calculus. Now this dr by dt, that is the rate of change of position, so I can write this as v. So this is minus v dv by dr. So what this is indicating, that there is a variation in the velocity with respect to the distance from the center of the earth. Now you can rearrange the equation and you can write v dv, that is equal to g r naught square 1 by r square dr, and here we have the negative sign. Now what we have to find out? We have to find out the velocity, and that velocity is changing. So we will integrate this equation on both sides, and at r is equal to r naught, means when it is at the surface of the earth, you have projected it with velocity v naught from here. So the initial velocity is v naught, and after reaching a height r, the final velocity is v. Now what we have to do? We have to integrate this equation. So when we integrate this equation from this, on this left hand side, we will get v square by 2, and that is v naught to v. So upper limit is v, lower limit is v naught, and here we have minus g r naught square. And if I solve it, so I will get minus 1 by r, and the upper limit is r, the lower limit is r naught. So if I solve it, v square by 2 minus v naught square by 2, and here we have minus g r naught square. So this is minus 1 by r, and minus this is plus 1 by r naught. Or I can write it as g r naught square, and I can write, or you can have minus sign here, and I can write 1 by r naught minus 1 by r, or I can again write g r naught. I have taken this r naught common, so I will get r naught instead of r naught square, and this is 1 minus r naught by r. And finally I can write v square, and that is equal to v naught square minus 2g r naught 1 minus r naught by r, or you can write removing this square and put under root here. So this is your final answer. So the velocity after reaching a height r will be this v. So this question is very interesting and a pure calculus based question. So the basic thing required to solve such type of questions is to first find the basic physics involved and to visualize the situation, and that you can do by drawing the diagram, and after plotting the diagram or drawing the relevant figure you can have an idea that how to proceed.